Hey everybody, welcome to the Smash News Network. Welcome to the Daily Space Weather. Thanks for tuning in. I'm your host Dan, aka smAsho from smashomash.org and smashomash.com. Our first area of checking things out is the sun at 94 angstroms. We've got an active region rising in the northeast, as well as the largest sunspot of cycle 25 to date. We've got the highest radio flux we've seen since 2016, and some more sunspots moving into a setting mode there west of the center longitude. We also saw some more C-class flares, some coronal mass ejections, lots of stuff going on, so don't go anywhere. Solar flares, sunspots, and coronal mass ejections. Oh my. Next thing we're going to do is we're going to take a look at the view from Stereo A, located out here at Lagrange Point 5. Looking at the sun in this sort of an orientation. And the Earth will be off to the right from this next pane. Don't be a pain. Don't worry about that coronal mass ejection. It's facing the opposite direction of the Earth. It's not even pointing toward Mercury, which you can see there above the coronagraph from Stereo A. Yes, exciting stuff happening. Now let's go back to Lagrange Point 1 here to look at some more earthly views. We're going back to Lagrange Point 1 for our HelioViewer movies. First, the LASCO C3, and I just wanted to show this because it's a prime example of what a halo coronal mass ejection looks like. So even though this one's facing the opposite direction, this is what an Earth-facing coronal mass ejection will look like on the LASCO C3. Allow me to get off the screen to allow full views of our HelioViewer movies coming up, and they are fantastic today. Just epic. So, here we are at HelioViewer, and we're going to take a quick look at the fields here. There are the magnetic fields, and check out the size of sunspot 2786. Its umbra is larger than the entire planet Earth. And these sunspots are actually interacting here, 2785 and 2786. Here is 304 angstroms. And we'll zoom in here real quick. There is a great fade to the fields. A bunch of filaments there, and there is still a significant potential for Earth-facing coronal mass ejections to be happening. The heck? Oh, I'm on. Okay, there we go. There we are, and there's 304 angstroms faded to 171. Great view there of the local yellow dwarf. The 10.7 centimeter radio flux is up to 100 solar flux units. And there's the graph from Solon.info for the last year. Again, highest levels of radio flux we've seen since 2016. And we saw a 245 megahertz radio burst also. It was quite short. Those are often associated with solar flares. And one of the only ways we have to predict when a solar flare might occur is the 245 megahertz radio flux. We'll talk about that in a later video, perhaps. Next, we're going to look at the LASCO C2 and the 304 angstroms solar view here. We've included the Earth scale. Again, there is a bunch of plasma down in this area, not particularly visible when looking directly at a bright object like the sun, but it is still there, and there is still potential for it to get ejected in an Earth-facing fashion. We'll keep you posted. It's part of the reason why we have the channel in the first place. Next, 131 angstroms, and this, along with the 94 angstroms, which we showed you in the first view, takes 10 images per minute instead of only 2. So this is 5 times more images than you would see in all of the other wavelengths except for 94 angstroms. And you will see a solar flare happen here. It's a C-class. right there toward the end of the video. Next, looking at just the southern hemisphere because it's where the current activity is located. Check it out, what a view. Sunspot 2783, Sunspot 2785, and 2786. Next, how about some 335 angstroms? This is another ionized UV emission spectral state of iron. Great view of those solar flares and activity there. And there is interaction between Sunspot 2785 and 2786. And 2786 is a beta class sunspot. It's got some significant umbre trailing it. And the chance for M-class flares continues to rise here. Here's an extreme close-up in the same wavelength. Absolutely fantastic imagery here from the SDO. And here's my personal favorite, 171 angstroms. Again, there is a C-class solar flare that happens here. That happened at 0400 Universal Time. Right on the nose was the peak of that solar flare. And don't confuse solar flares with coronal mass ejections. We don't need to see solar flares to see a coronal mass ejection. The sun is able to fling plasma out into the solar system without any solar flares detectable from Earth. And before we move on here, let me just check the life of the stream. Up here back on your screen. And if you've got any chats to leave us, feel free. Thanks to our new Twitch viewers, etc. That's actually yesterday. And today's Smash Lights will actually be a separate video. So it will not be included in today's Daily Space Weather. Because we'll be talking about, oh noes. It's the, hey, get out of here. Get, all right. We would invite you to follow us on social media, check out our links, etc. Visit the links below the video, wherever you're viewing, whether you're viewing on YouTube or BitChute. Check out the links. And don't forget to use the promo code on checkout for all Teespring orders through Christmas. So whether you're buying gifts for folks or if you're treating yourself to some of our merch, you can link to all of that at smAshomash.com. smAshomash.org will also link you there. Today's featured product is the orange Mansa shirt. Planning on going hunting this winter? Well, nothing says don't run me over or shoot me like a blaze orange piece of clothing. And we would invite our viewers to please Mansa. It's nonpartisan. Make America not suck again. Have you noticed a little bit of suckage going on in the U.S.? Yeah, same here. Well, it's up to you to make America not suck again, not the government. And moving on. Again, you can link to all of that stuff from smAshomash.org, our homepage. Perhaps consider checking out our Condensed Matter Matters mask. Yes, Condensed Matter Matters. We've made a mask about it, as well as some new shirts, including this print all over shirt. Yeah, it's got a Condensed Matter yellow dwarf on the sleeves and on the front and the back, along with the smAshomash.org logo. Perhaps a great gift idea? And there's also some other cosmology shirts, such as the Cygnus X3 Deneb shirt. Yes. Again, you can link to all of that at the Smash Store and smAsho Store, linkable at smAshomash.com. If you haven't been there, check out our homepage. It's quite beefy. And check out our other social media. We're all over it. Links below the video for that. Instagram, Facebook, etc. Thanks to everybody who follows us. If you enjoy the content on YouTube, please press like and subscribe over there. youtube.com/smAshomash. And we've got exclusive content on all locations. So, exclusive content on YouTube. Check out our smAsho.org presents the Sun series. Expect a lot more videos in there coming out. I mean, geez, 43 views on our latest. We get more views on our daily space weather than we get on our The Sun series. And we are going to talk cosmology in a moment. Again, we are streaming live to Twitch right now. If you want to see the content come out sometimes as it happens, it's twitch.tv/smAshomash. And also check out our playlists on YouTube, youtube.com/smAshomash/playlists. You'll find our Smashlight segments in there where we talk about whatever we want. And we've got other stuff besides astronomy, cosmology, and space stuff. Again, thanks to everybody who's encouraged us to create more content. Cheers. Let's move on to a cosmology segment. Now, today we're not going to roll any dice to figure out what to talk about. What we're going to do is we're going to talk about pulsar J1135-6055, part of a pulsar wind nebula. And what's interesting about this is this image you see before you right here. And what the heck happened? So this article's on phys.org's Astronomy and Space section. And check out the jets coming out of the poloids of this pulsar. It's quite an interesting system. And I would note that the medium in which the ejecta is ejected into determines the shape of the magnetosphere. The medium in which the ejecta is injected into determines the shape of the magnetosphere. In other words, if this medium is at a higher sort of magnetic wind speed than these jets, you're going to see the jets pushed back. Otherwise, you might see the jets coming out nearly perpendicular to the toroid, which is like in that shape, and you can actually see it in the image there. Great article here about jet-like structures from pulsar J1135-6055, the catchy name. And if you want to look this up, here it is on Aladdin Light. And this is the Chandra X-ray telescope here. Fantastic view there of pulsar J1135. And you can see that smiley face-like structure. And the X-ray emissions. There are the jets. Yes, it's a good one. And we don't want to spend too much time talking cosmology today as there's too much basic heliophysics stuff going on. Allow me to get back off the screen. We've got cosmology segments, by the way, on the playlists as well. Thanks to our patrons, a true source of funding, our cosmology segments and all the videos are brought to you in part at massive personal expense and risk by us, and also in part by our patrons. Please consider becoming a patron at patreon.com/smAshomash. We recommend joining at the $3 per month level, as we'll be getting rid of the $1 and $2 per month tiers by the end of the year. Thanks, patrons, the true source of funding for the content, besides our own massive personal risk and expense. Next, let's look at the real-time solar wind. Here's what's currently going on. And we see the BT/BZ diverging from the zero line here over the past 8 hours. Phi angle's been shifty over the past 8 hours. Current solar wind density around 4 protons per cubic centimeter. Current solar wind speed 384 kilometers per second. A pretty baseline solar wind speed and density. Here is the KP index, having come down from 3. And by the way, we are in the South Pole oriented current sheet. An unexpected change. Here's what's going on in the geospace. It's our daily geospace magnetosphere movie. It's 4 hours of data, courtesy University of Michigan. And our ground magnetic perturbations map has been failing for the past several days. We will have to look up a new magnetometer data set to show you the ground magnetic perturbations. And I just let that refresh there as it's 4 hours of data, and it refreshed in the middle of the feed. And again, these are the dangers of streaming live. Cheers. Anyway, there's the past 4 hours. Here's a still image of the ground magnetic perturbations, and we don't see very many perturbations with such a low solar wind speed and density. We don't see any major proton strikes, no surprises there, as we haven't had any coronal mass ejections hit the magnetosphere for quite a while. And there's the solar flaring situation. So again, we saw another C-class flare, and once again, that one happened right at 4 o'clock, 0400 Universal Time. If you want to go make yourself movies of that, that's when the solar flare happened. I like to know what's going on above my head, so I use in-the-sky.org. If you're up before dawn, you may be in a situation like me where you see Venus just rising over the horizon, the third brightest object in the sky, entering into the constellation Virgo. Here's what's going on in the solar system. There's where things will be in a week. As the Earth swings past Mars and Mercury and Venus head around the backside of the Sun for another lap on the Earth. So again, we are in the other heliospheric current sheet. And it probably happened right here. Or maybe here. Or maybe both, as we could have snapped across. But in any case, expect some continued sawtooth patterns here in the ghost magnetometer. We'll show you why on the next frame. There's the top view ecliptic plane field plot, part of the National Sunspot Observatory. It's the Gong 2 data, as I like to call it. And you can see the Earth's potential field force line now in the South Pole current sheet. Unexpectedly quick, and it could have to do with that activity rising in the north or the recession of the North Pole coronal hole. Both things which we've seen happen, or a combination of the two perhaps. Another indication that there is another sunspot rising north of the equator. And here's the line of sight coronal hole field plot, and you can see the green fields here associated with that North Pole coronal hole have sort of receded back toward the pole. And the red has actually headed quite close to the equator, near to the spot where the North Pole coronal hole was located a couple days ago. So, and you can also see major changes in the B field shown in blue. Here's the same image here, which also shows you the solar polar fields in green and red. So South Pole, welcome to the South Pole oriented current sheet. Next, looking at the solar coronal magnetic field force plot, and that PFSS stands for Potential Field Surface Source. This one shows you closed potential field surface source lines in pink and open ones in black or in purple. And let's move on. We want the video to be fairly compact today. Here is an image of the Van Allen belts. Before we talk electrons, we like to show this just so folks have an idea of the altitudes of satellites and so on. So the SDO, the Solar Dynamics Observatory, is located about 22,000 miles away, just outside of the outer Van Allen belt, as shown here. And we've seen a little bit of a reduction in the electron flux here. The warnings don't look as harsh as they used to be. We still could see some communications failures and big GPS errors, especially around the equator at noon. There's the charging hazard situation, mainly in the southern hemisphere right now. Here's the 1-year chart of the electron flux. And let me just take a little break here to check the life of the stream and to see if we have any comments, and we don't. So let's continue on. Here is the Noaa Forecast, and we never made it up to these levels here. Above 10 to the 9th is what that forecast was for. We didn't see those levels, and that's a good thing. The likelihood of damage to satellites and communications failures and massive GPS errors dropped a little bit, and the current forecast is for this to remain level. And I have no comment as to whether I agree, but here's the 7-day chart of the GOES electron flux. If you're wondering where this measures, it measures at the ionosphere layer. In other words, at the bottom of the inner Van Allen belt. And here's the 3-day chart. Getting into warning territory here. Those N's and M's up on the top, those stand for noon and midnight time. Noon and midnight local time for the GOES 16 satellite. Here's a visualization of the total electron content. And we see anomalies once again over North America and Canada. Usually those highly dense regions are confined to the equatorial regions. Again, you'll see some massive GPS errors, especially over the Indian Ocean there. Next, we're going to look at one slice. Keep in mind, this one is the entire atmosphere all the way up to the thermosphere. Here's just the ionosphere layer. Not looking particularly anomalous to me. Leave a comment if it is to you. Here's the latest image. That one's coming in at 9:45 Universal Time. Let's look at volcanoes over the past 24. Kluchevskoye is still erupting, producing a 20,000-foot ash plume. Sumanosejima is still erupting, producing a 6,000-foot ash plume. Please don't hang glide over the caldera in the Ryukyu Islands near Japan. Fuego, volcanic ash not observed in satellite. Please don't pole vault or tightrope Please don't pole vault or tightrope walk the caldera. Sangay is exploding. Flight level 200, it's producing a 20,000-foot ash plume. Revenador exploding. Flight level 150. Sabancaya exploding. Flight level 250. And a 25,000-foot ash plume is not something to attempt the Fosbury flop over. Leave us a comment if you know what the Fosbury flop is. It has nothing to do with teraflops or computing or video cards or processors or front-side bus. Please leave a comment if you know what front-side bus is. Largest earthquake of the past 24 was not over a 6 magnitude. We saw some deep quakes such as this nearly 600-kilometer deep quake at a 4.4 magnitude near Indonesia. Looks like the largest of the past 24 was this 5.5 in the mid-Indian Ridge. Not a common spot for quakes, as far as I know. Another deep quake strikes near Japan. It's the Izu Islands. A 4.6 magnitude at over 430 kilometers depth. 114-kilometer deep quake strikes Argentina at a 4.8 magnitude. And a bit of a swarm here around Alaska there, as well as some likely magmatic activity striking Hawaii. Here's what's going on in pressure maps. I like to use windy.com. They've got a great mobile app, and I'm not paid to say that. This is the GFS forecast for where pressure will be tomorrow at noon on Thanksgiving. Let me bring that back. There we go. And if you're wondering where I'm located, if you're a new viewer, I'm located in Lehigh Valley, Pennsylvania, just west of New Jersey. And fortunately, the wind is usually blowing west to east in this area, and I usually can't smell the stench of the communist fortress of New Jersey. And let's move on to some more value-added services. We don't do weather videos yet, but it's coming. It's coming, folks. Mark my words. We're going to make meteorology videos. It's going to be a thing. Here are the jet streams of the eastern world, rather. And by the way, if you're wondering what we're looking at, it's the 250 hectopascal winds. And this requires a lot of computer interpolation to get this data. Cheers to nullschool.net. We've got a significant low pressure system here in the Southwest Pacific. Here are the jets of the Western world. And look at that extreme bend over the North Atlantic. Get ready for the articles to tell you that Greenland is melting. OMG, OMG, Greenland is melting. Apparently, having 5 meters of snow nearly from coast to coast all summer long equals melting. Some seriously strong jet streams there, a major intensification here. Look at the fully northward flow there. I don't know what the speeds would be. Let's see if we can find out. 210 mile per hour jet streams there. And we saw major lightning here over the south central U.S. I like to use lightningmaps.org. It looks like that's subsided, but most of the lightning now is located in the daytime portion of the planet. And check it out, major lightning storms there, especially over Arkansas. Also some serious strikes over Missouri, Texas, Louisiana. It's the Go 16 Lightning Mapper, a normal feature here at the Smash News Network. Another normal feature is me, your host Dan, aka smAsho Mash, vanishing to allow a more complete view of the screen. Next, we're looking at a major line of storms. Some seriously turbulent weather happening over Kansas. Please leave us a comment if you've been sent to Oz. And that stuff is moving almost due east. Let's see if we can get some insight into it. Here's what's going on in the cloud layer. And check out that low over the Missouri-Nebraska border. I mean, the Missouri-Kansas border. And let's learn how to speak English. Let's look at the water vapor map next. It's part of the NASA GOES interactive weather satellites. We show it daily, as this gives more insight in a glance than probably any other weather phenomenon in the U.S. The water vapor map allows us to see water vapor not condensed onto clouds, and it has nothing to do with the Doppler radar, which are ground-based systems measuring movement in the air column. We'll zoom in on that zone over Kansas. And remember, folks, in the northern hemisphere, the most dangerous part of a thunderstorm is the northwest corner. It all has to do with atmospheric physics, and we won't get into an atmospheric physics lesson today, but there's what's going on with that situation. And that is why that storm in the middle of Kansas is stagnating. There's a bunch of dry air, as this air here is much more massive than the surrounding air, and it's causing massive pressure gradients. Hey everybody, thanks for tuning in. Remember, keep your head and arms inside the smash plane at all times. We've got bonus features. Today we're going to show you the 1700 angstroms 48-hour SDO video to show you the last 2 days of sunspot activity. We're also going to show you the colorized magnetogram, because it's a regular feature at the end of our videos. And you can see sunspot 2784, sunspot 2783, 85, and 86 down there in the south. There's 2783, still beta class, and this still has potential to produce M-class flares. And so does this system, and it's quite complex. A bunch of significant umbra back in this area, trailing sunspot 2786, and it looks like 2785, which is this one, is still alpha class. Here's the intensity gram, and you can see sunspot 2783 is beta class, which means higher potential for solar flares and coronal mass ejections. And there are the other two, 2785 and 2786. Look at all the umbre trailing that. The largest sunspot by far, so far, during cycle 25. Last but not least, check out the size of sunspot 2786. It's large. It's in charge of most of the activity. And we'll zoom in here on the southern hemisphere before we close things out. Thank our viewers. Thanks for tuning in, folks. Remember, stare at the sun. Don't drink it. If you do, don't drive. Seriously, don't drive. Welcome to the DR Renaissance. Again, visit our links. Help to support the channel if willing and able. If you enjoy the content, press like and subscribe and share on your social media. We'll see you next time here at the smAsho News Network. And may that solar wind be at your back.